Hi and welcome back to my YouTube channel. Today we are starting a new topic, consuming energy resources. This is topic 9 in Edexcel GCSE Geography, specification B. So to start off with, we're going to get to grips with a couple of key terms. These key terms are going to be useful to you throughout the unit. If you don't know them in advance and you can't get to grips with them in the context of this unit, you're going to find it really difficult. So we're going to start off with those. We're going to come back to those and practice them throughout the course. Then we're going to move on to looking at different types of energy resources. Where do we get our energy from? How do we turn that into usable electricity? And how can we classify those different types of energy sources and really understand sort of how we can compare them so that the rest of the unit, then we can look at our consumption. So just before we get started, I wanted to remind you that although you can work through the PowerPoint as we are here, you are expected to be writing your answers in your worksheet. So your worksheet will look just like this, and you can type your answers straight into the worksheet and we can mark it from there. Your worksheet is going to have your name at the front and then L1 classifying energy resources for the first lesson. So our first task is a key term matchup. All your key terms are up here at the top and then the definitions are down here. You should know a lot of these. Some of them you may have to work out either by working out the others first and through a process of an elimination deciding what they are, or by reading carefully the definition to see if you can work it out. So say, for example, energy resources such as coal, oil, or natural gas formed from the remains of plants and animals that lived millions of years ago. So what would we find that we would discuss the remains of plants and animals that lived millions of years ago? When we talk about those things, what word do we often use? And then we're talking about energy that comes from that. So coal, oil, and natural gas are all fuel types, and the ancient remains of plants and animals frequently call fossils. So that first answer is, of course, fossil fuels. Now, be careful. Some of these definitions are quite similar. So, for example, what might be the difference between recyclable resources and renewable resources? What is the definition difference between renew and recycle? So if something's being recycled, it is being reused. You can take that same material and use it again, transform its composition and use the same material again. Renewable resources or renewable energy will be something that doesn't ever deplete. It isn't diminished, isn't made smaller by using it. It may get replenished or replaced without much issue. Okay. So pause the video, do your match up for me. It should take you about 5 minutes. So let's have a look at some answers then. Here we go. These are the answers that we were looking for. As we mentioned, fossil fuels is the first answer. Renewable energies are natural resources such as solar energy, which will be regenerated by its environment. And one thing that's worth putting in here that I haven't done, and that's probably a mistake on my part, is that we're talking about within a human lifetime that these are renewable. The third one is a word that I don't expect you to have known sort of confidently before this unit started, but it's a really important process. So fracking or hydraulic fracturing is the other term that you will learn about this in chemistry with, is a process of drilling down into the earth and getting an oil mixture and oil and gas mixture out of the rock by sort of creating fractures or cracks using very, very high pressure water. So it's a way of extracting oil and gas, which is quite controversial. So it's something that we're saying right here at the beginning. You need to know that this word fracking is quite going to be important. Go and have a look at some videos, do a bit of research if it's interesting to you. We are going to do a whole lesson on fracking coming up. It's really, really key term for this unit. So this fourth term here, carbon footprint, is a measurement of all the greenhouse gases an individual produces, and that is really a measure of how much energy you use. You might think of the carbon dioxide that you produce in terms of your respiration, your breathing, but in addition to that, most of our energy consumption actually produces carbon dioxide as a byproduct. And the ways in which we use energy are quite hidden in our daily lives. So we use a carbon footprint to sort of measure the impact of how we live our lives. One more obvious example that you can think about is how you travel to school. If you walk to school, you have a very small carbon footprint because you haven't used any energy other than the food that you've eaten to get yourself to school. If you take a train, then you have a slightly bigger carbon footprint because there's energy going into that train to transport you around. But that energy is being used by all of the people on the train. So there's quite a lot of people being moved around. It's quite efficient. If someone drove you to school, then that was not particularly efficient. It probably had a much higher carbon footprint because there was a lot of petrol that was used in transporting you and that maybe 1 ton car to school and back home. This can get way more complicated than just our travel arrangements, though. It can even go so far as thinking about how far our food has travelled. For instance, did the green beans that you ate at dinner time come from a local farm, or did they come from South America? Did the roses that I give to my mother on Mother's Day, did they come from the UK? Are they English roses? Or did they come from Africa? So a lot of our products that we buy have traveled long, long distances to get to us and have used lots of energy in their production, and that can increase our carbon footprint as well. A recyclable resource is something that I referred to earlier on, and this is something that can be reused so that it can be last longer into the future. Now, most resources are not recyclable. They are either renewable or non-renewable. But there are a few that are recyclable, and these are particularly most often natural resources that are part of the sort of carbon cycle. So, for instance, biofuels start out as plants that have grown, absorbing carbon dioxide from the air. We then turn them into or process them into a format that can be used as a fuel, say, for instance, ethanol, which then might get burnt and re-release the carbon dioxide back into the air, where we hope it will be reabsorbed by another plant. So you can see how that is a recycling of the carbon through the carbon cycle. Non-renewable resources are a really key one. We need to understand that some resources were formed so long ago, like coal, oil, and natural gas, that they are effectively limited in supply. Because these resources take millions of years to form, it's not reasonable to expect that we will have any formed while humanity is still on this planet, and so they will eventually run out. So we say that these are resources that are non-renewable, and one way of thinking of them is that they are a stock. They exist in a certain amount, and the more we use, the less there is available. So it's as if you had a stockpile of resources and you're using it, and the pile of resources is getting smaller and smaller. Renewable resources work differently then. We often call them flow resources because they are not resources that as you use them, they diminish. They don't get smaller necessarily. So the wind will continue to blow because it is a natural process equalizing air pressure throughout the world. There is no stopping the wind blowing, but if we can harness it, we can use that energy indefinitely, forever. Yeah? So we're saying that this is a renewable resource, it's being replenished, the wind continues to blow continually, but it is not diminished, it is not going to run out. So sometimes we call this a flow resource. So, lots of pictures here. I want you to have a think about what types of energy that we may have already mentioned, but that you can think of off the top of your head are shown in these images. Some of them are obviously going to be a little bit easier than others, but give it a go, pause the video, see if you can work them out for me. So let's have a little look then. What have we got that's really nice and obvious? I think over here on the right hand side, we've got some pretty obvious ones. So this one up here is of course coal. Okay, coal, the power of the Industrial Revolution, or coal powered the Industrial Revolution is one way of thinking about it. It is the classic fossil fuel. It is also quite dirty in terms of its emissions. The second one here is natural gas, which is generally methane. You will see it in school science labs, in your Bunsen burners, you'll see it at home on a cooker. It's also often used in boilers to heat water. Lots and lots of uses for natural gas. You can even, for some cars, put it in your car as fuel. This one down here then, perhaps you have seen this method of extraction or production of this resource. It can get turned into multiple different things, including the petrol or diesel that goes in your car. We often put it in a barrel like this. It is oil. Now, oil is an interesting one, and it's something we are going to come back to. It is the one of the most powerful fossil fuels because it has such a complicated chemical structure. This is something that you are going to look at in your chemistry section of your science GCSEs. And one of the things that you're going to look at for oil is actually how those hydrocarbon chain lengths vary. So when we first extract oil from the ground through this pumping process, most commonly, it comes out as a very thick, black, mixed up substance, which we call crude oil. Crude oil then needs to be separated out into all of its different parts. So the type of fuel that you extract from the ground directly is not exactly the same as the type of petrol you would put in your car. To get it from this to that requires quite a lot of processing, and there are lots of things that we can produce. So this is an American picture, but gasoline is petrol, diesel is another type of fuel, a little bit thicker and heavier. It has more energy in it. So what's interesting is that these become more energy dense as we go further up. Jet fuel is a really interesting one. So if you ever see a rocket take off, that is something that requires an enormous amount of energy. It needs to be quite energy dense. And you might be shocked at the things that we do make out of oil. It is not just being used as a fuel, it's also being used to produce plastics, it's being used to produce agrochemicals, so like pesticides and fertilizers. It's even used in some makeup products. Say, for instance, Vaseline is a really obvious one, which actually uses, and it will literally say on the tub, petroleum jelly. It is an oil product. So what else on here might we know then? We've got our classic fossil fuels over here. Let's go for some pretty maybe obvious renewables. This one up here is solar energy. I don't know if you can tell, but this is an enormous array of solar panels. This particular one is the largest reflecting array in the world. It is in the Sahara Desert in Morocco. This one over here is solar energy. Another one then down here, quite obvious, I hope, is wind. These are wind turbines, and you'll see them all over the UK and elsewhere in Europe. Really promising source of green energy. This one here is water, and we can use water energy in a variety of ways. We tend to call it hydroelectric power. And what we're effectively doing is allowing the flow of the water to turn a turbine. Just like the wind is turning these turbines, there will be turbines inside our dams which are turned by the water flowing past them. That turning is really key because it allows us to create electricity. So let's have a look at some of the less obvious ones then. This one up here is biomass, and it is a hugely variable source of energy. So some biomass might be in the form of alcohol fuels. We mentioned ethanol earlier, and when you have ethanol, you can burn it pretty much like it's oil. You can even, alter car engines so that they can burn ethanol, and that can be produced from a variety of different crops and different alcohol fuels, whether that's soybeans or sugar. Then we've got sort of two different types of gas that comes out of landfill or from sort of waste, and then you can burn garbage. Now, it's not a very efficient burning product, but you can burn it and have energy from it, and that energy can be used, say for instance, to heat water into steam, which will turn a turbine and again generate electricity. then in its most basic and traditional format, if you have a log fire or you cook your food over a fire with wood as the fuel, that is a type of biomass energy. Okay, so this is one that humans have been using for millions of years. Maybe we don't think of it sort of automatically as a source of energy anymore, but it is a really key source of energy, and it may provide some real solutions as we look to the future. This one up here then is another renewable source. It is geothermal energy, and I just want you to have a look at this picture really carefully. I hope you can see that there is snow and ice all over the ground in this image. This is actually a photo of a geothermal energy plant in Iceland. And what I hope you can also see is the plumes of steam that are being produced, because what we are doing here is we are tapping into underground sources of heat energy to heat water, which then again turning it into steam, turning a turbine, and generating electricity. That warm water then gets put either into a cooling tower where you get all of this lovely steam from, and we inject it back into the ground then to draw it back up again. Now, this can work in a small way in most places, but it is very, very effective where you are in a tectonic landscape and there is magma quite close to the surface. So somewhere like Iceland with lots of active volcanoes has huge potential for generating geothermal energy. Of course, here in this section, we are seeing so many words that are useful just to identify and break them down. Sol meaning the sun, geo meaning the earth, therm referring to temperatures, bio referring to living things, so our crops, our trees, and other things all having been living and then producing energy through their biomass. With water, we've got the prefix hydro. So there's quite a few there for us to remind ourselves of. Finally then down here, perhaps a little bit funny, The Simpsons, Homer works in a plant that deals with this particular type of energy. The most common sort of resource that we would use to generate this energy is uranium. It is quite dangerous if handled improperly. It is nuclear energy. Okay, and we will research that a little bit later on today. So, reflecting on those energy types that we've just talked about, and also the definitions that we talked about at the beginning of the lesson, I'd like you to combine that knowledge now and just categorize for me whether or not these types of energy resources are renewable, recyclable, or non-renewable. And I want you to think of whether or not they are sort of physical resources. Are they something that is produced by a natural process, or the features of the landscape, for example, the sunlight that we get from the sun? Or are they biological or mineral? Are they something that we have to extract or dig up or manufacture? And they've either grown naturally, like trees and plants, that would be our biological, or mineral, things that are mined or quarried, we have to dig it up. Okay, so putting these into the right categories, there is not necessarily going to be something in every box. This task should only take you about 5 minutes. Pause the video, off you go. Okay, let's look at some examples of answers then, please. So hopefully some of these were reasonably easy to do. Solar should have been renewable. Is it a physical, biological, or mineral thing? It should be under physical, okay? It is sunlight. It occurs naturally. It isn't something that we have to wait to grow. It's not something we have to dig out. It's just there. Natural gas, on the other hand, is a mineral thing. We have to extract it from the ground. It's not renewable. It's not really recyclable either. So it goes under here, under non-renewable. So here are all of your answers. So coal, crude oil, and natural gas, all three of our fossil fuels, non-renewable, biological, mineral. Our renewables are mostly physical. So solar, wind, geothermal, hydrological energy, those are all under renewable and physical. So it's this middle section here that's a bit unusual. Our recyclable material is our nuclear material. Now, it's recyclable because although when we react uranium in a nuclear reactor, we don't actually use all of it, and it can be reprocessed as it retains its radioactive qualities to be reused in other nuclear processes to generate energy. So it can actually be reprocessed and be reused. Our biological and mineral items down here then are our biomass or biofuels or biogas, which is methane. That was all in that one category before of biomass, but just thought I'd sort of show you the different words, all of course beginning with that prefix bio, which means life. So biomass being the mass of it, biofuels being something you would burn, and biogas is a very specific type of biofuel, i.e. methane. So our final task today then, I'm going to ask you to complete a little bit of research. And what I want you to do is to research 4 types of energy extraction. I've done the first one for you for wind power, okay, as an example, and I've started the crude oil one. There's 3 words that you need to work out that go in there. And for each of these different types of energy, what I would like you to look at is how is the resource turned into energy? So actually just like, okay, you have a spinning wind turbine. How do you turn that into electricity? How does that actually work? Okay. What are some of the waste products of this process? And there may not be lots of them. So for example, with wind turbines, we've got not much waste from the actual energy production, but in constructing the wind turbines, there's a lot of metal in there, there's a lot of wiring, so there is a huge amount of resources that's being used in constructing those wind turbines. And then I want you to think about where in the world has a large supply of these resources. Okay, now that might be, if we're talking about something like oil, where has got lots of that stock reserved or left still to be taken out. Or if we're talking about something like wind, which is a renewable resource, where are the best places in the world to get that? So if you want to think about the Sahara versus the UK, well, which one is going to be better for solar power? Hopefully, as most people would assume, although you can get sunlight and therefore solar power anywhere in the world, it is going to be better where the sunlight is really, really intense. So somewhere like the Sahara, which is quite close to the equator, gets very intense sunlight, has very few cloudy days to obscure that sunlight, is actually going to be an ideal spot for a solar farm. So let's take ourselves through this example of wind turbines. Wind turbines work in a very particular way. You should be able to see from this picture that they are shaped kind of like a fan, and that means that they're designed to spin. So as the wind blows, these fans or these blades spin through the air. That turning motion is kinetic energy, it's movement energy, and that movement energy can in fact be turned into electricity by using a very clever piece of equipment called a dynamo. Now, I expect that you will have learnt about this a little bit in physics, but maybe you haven't got to that unit yet. So a dynamo in its most simple form is the same thing that you put as a bike light on your pedal bike, okay? It is basically a coil of wire, like a spring, with a magnet in the middle. The magnet spins because these blades are spinning, and as the magnet spins through the metal coil, it generates electricity by moving the electrons around the coil. That electricity can then be taken through wires onto land and either stored in a battery or put straight into the national grid, where you might use it to turn on the light switch at home. Okay. Now, we can put wind farms in loads of different places. We can put them on land, and sometimes you may have seen them on land. But in fact, if we want to make the most out of our wind farms, we want them to have a really strong, steady, powerful wind, which means that we don't want the wind to be interrupted by buildings and things like that. That actually means that some of the best places in the world for wind farms are actually not on the land, but on in the ocean or in the sea surrounding the land. Now, they have to be near enough to the land that we can run cables or wires back to the land to bring the electricity back, but actually putting them in the sea is a really, really great idea. Of course, it does make it way more expensive than putting them on the land, but if they're going to be more efficient, that is a trade-off that sometimes we're willing to make. So actually, if we look at this map here of the UK, it tells us about wind power around the UK. And what you'll notice is that the closer we are to the shore, the lower the wind power is. And that's because these areas are a bit more sheltered. Yeah, the land itself is blocking the wind from blowing. And even if we look here to the eastern side of the United Kingdom, the wind power is much weaker than it is up here on the west. And that is because there is the unobstructed flow of air across the Atlantic Ocean, which is creating strong winds in these areas. In fact, when we looked at the UK's physical landscape, we said that that long, unobstructed area of sea that helps the wind blow is called the fetch for a wave. So, where on this map would you want to place a wind farm if you wanted to maximise the amount of energy we're getting from it? And hopefully you're going to say somewhere up here in the North Sea. I would like you to watch this video up here, please. But if you want to read more about wind farms in the UK, you can click on this link to the Caboodle page to go and see that. So the video here is very brief, but it's all about Scotland's potential to host wind farms and this plan to have one of the largest wind farms in the world be built off the coast of Scotland.
Plan for the world's largest floating wind farm gets the green light.
You are going to do a little bit of research for me, as we've discussed, on crude oil, solar power, uranium or nuclear power, and natural gas.